Okay, so we have talked about sine and cosine functions, which can also be referred to as, do you remember the name? It's kind of a weird name. Yeah. Sinusoidal, or sinus and then oidal, which is fun to say. And remember, they're also periodic functions, which means that they follow a certain pattern that repeats over a certain interval in both directions forever. So we've seen what they look like. And just like we did in the first unit, just like we did with just like we did with radical functions in unit 2, we can transform them. We can stretch them vertically and horizontally, we can flip them, and we can shift them. Okay? Slightly different with sine and cos functions, but the general pattern is still the same. So I want to talk about stretches and flips. So here we have, just to review, you've been given the cosine function. Okay? On this graph. So let's just review some of the properties. Do you remember the amplitude of the cosine function? 1. It's the distance from the horizontal line that splits the function in half to the maximum or minimum. So it's 1. I'll do red since that one's it. The period is how long it takes horizontally to complete a cycle. So if we start at the y-axis, if it starts up here, after how long horizontally does it reach up here again and start its pattern? 2 pi. So that's the period. The zeros occur at pi over 2, and then every pi after that to the right, and every pi after that to the left. So it occurs at pi over 2, plus every pi to the right and left by 1, -1, 2, -2. And what is 1, -1, 2, -2? They are integers. Again, you don't have to worry too much about that. What's the y-intercept? 1. Now all these mean is, what's the minimum y value and the maximum y value? So where does it bottom out? What y value does it bottom out? -1, and it tops out at positive. Okay. Vertical stretches and flips. Remember, that's the letter A that goes in front of the function. Stretches it vertically, either out or in, okay? And it could flip it. It doesn't flip over the x-axis, though, with trig functions, not all the time, sometimes it might. It flips it over its midline. So if it's moved up and flipped over, you don't flip it over the x-axis, you flip it over the midline. But we'll see that shortly. But just remember, A means a vertical stretch by a factor of A, absolute value, because we don't worry about the negative. Negatives aren't involved in stretching. Negatives are involved in flipping. So the function is reflected, in this case, it is reflected in the x-axis, but really, the x-axis is also the midline in this case. So that's what's going to happen. So if you think about it, what's going to get affected? The amplitude. Because in regular cos, cos theta, the amplitude's 1. But if there's a 2 in front, isn't it going to stretch it from 1 to 1 times 2? If it's 3 in front, it's going to stretch it to 1 times 3. If it's half in front, it's going to compress it or stretch it in. Okay? So the amplitude is always going to equal A. Whatever number is in front of a trig sine or cos function is the amplitude. And it makes sense because what number is technically in front here? We just don't write it. What? So here for B and C, we're stretching. We're stretching by a factor of 3. So the amplitude goes from 1 to 3. It's stretched 3 times out. This still stays the same. That doesn't change. But maybe before we fill the rest of this in, let's see what the graph looks like. So instead of 1, it's stretching 1 times 3 up here. Well, this is 0. 0 times 3 stays there. Doesn't stretch anywhere if it's sitting on the x-axis. This stretches down to -3 here. That's the same. That goes up. That's the same. So you can kind of see the pattern that it follows. It's like that. And again, you can go into the negatives. Here it wouldn't stretch anywhere because it's on the x-axis. Here it's at -1. So it goes to -1 times 3, which is -3. Here it doesn't go anywhere. Here it's 1, so it goes to 1 times 3. And here it doesn't go anywhere. So it's going to look something like that. It just stretched vertically. Did the zeros change? No. So it's still the same thing. Pi over 2, and then plus 5, plus 2 pi, plus 3 pi, and then minus 5, minus 2 pi, minus 3 pi, or plus pi k, where k is an integer. Y-intercept changed. It's now 3. The minimum value changed to -3, and the maximum is the same as the y-intercept, which is 3. Right? This time the stretch is 1/2, which means it's going to stretch in or compress. The only thing that's going to change is the amplitude. Instead of 1, it's going to be half of 1, or a half. The period, the time it takes to complete a cycle does not change. So now what you've got to do is, first of all, they're not going to move anywhere if they're already on the x-axis. Remember, I'm referring to the red one, not the purple one. Here, it's 1, but the new one is half of 1. Here, it's -1, but the new one is half of -1, and so on. So it compresses. You get that? This didn't change the zeros. But the y-intercept changed. to a half, the minimum change to negative a half, and the maximum change to positive a half. So those are stretches. The last one is not a stretch, it's a flip because of the negative. Okay? So remember, the amplitude is the number in front without the negative. It's the absolute value of the number. So the amplitude would be still 1, not negative 1. The negative just flips it. This is not going to change either. But let's see what the graph looks like. So looking at the red graph, remember the midline here is this, the x-axis. So if you take the red one and flip it over the x, well, all the points up top will go below, points below will go up top by 1, like so. But all the points that are already on the x-axis flip over the x-axis and land on the x-axis again. So it's going to look like that. So it's very similar to the red one, except it's flipped over the x-axis. And it's going to look something like that. The zeros didn't change. If we started pi over 2, it's every pi to the right and every pi to the left. So that didn't change. But the y-intercept did. Negative 1. But the max and min are the same as the red one. It's just it's been flipped, but the max and min don't change. So the min would be negative 1 and the max would be 1. So that's vertical stretches and flips. The last one I want to look at before we move on to shifts are the horizontal stretches and flips. And again, it follows the same trend as transformations we've been doing previously. So remember, if there is a function, or sorry, a letter, a number inside, in front of the x being multiplied, that number is, sorry, just blank. Now I've lost my train of thought. That number is b, that refers to a horizontal stretch. Okay. And remember, the horizontal stretch, the actual stretch, when we graph it or we put it in mapping notation, we don't times it by b, we times it by 1 over the absolute value of b. We saw that. Where this is actually a number like 2, 3, 4, 5, it's stretching in horizontally or compressing horizontally. If it's a fraction between 0 and 1, it's actually stretching out horizontally. Okay? Or expanding. And then if b was negative, we flip it over the y-axis. Same thing applies to the sine and cos or sinusoidal functions. Okay? So what's going to happen when we stretch horizontally or stretch horizontally in or out? Well, the amplitude's not going to change this time, but the period will. Okay, and how, right? Because it's going to change horizontally. The period's normally 2 pi for cos or sine, but if I stretch it in, it's going to change. It's going to shrink. If I stretch it out, it's going to expand. It's going to get bigger. Okay. Well, what's the normal length of a period for sine and cos? What's the normal length? 2 pi. And I have to multiply that by the horizontal stretch factor. So to figure out how much it stretches, we use 2 pi over the absolute value of b. We don't just use 1 over b, we use 2 pi because a regular period length is 2 pi. Let's see how it looks when we graph some of these. So the first two, we're going to do a couple of horizontal stretches. The last one, we're going to do a horizontal flip. And then the first one is just a regular sine graph, which remember is a little bit different. Doesn't start at 1 like cos, starts at 0, starts the cycle at 0, 0. What's the amplitude for sine? 1, period. 2 pi, because we haven't stretched or done anything yet. Okay. What are the zeros? It doesn't start, they don't start at pi over 2. They start at, where do you see a 0? Sorry? Pi. And then every pi to the right after that, every pi to the left after that. So it's not pi over 2, it's just pi plus every k pi, where k is an integer. No, did I do k pi or pi k? I want to stay consistent. Pi k, right? Yeah, let's stay consistent. Yes. What's the y-intercept? 0, I heard it. Min value? -1, max? 1. Okay. All of these, the amplitude is going to stay at 1, right? Because there's nothing in front to stretch it, nothing in front to stretch it, nothing in front to stretch it. So when I do all my different colors, what did I do? I did this one first, and then I did this one, and then I did this one. They don't change, right? When I do it horizontally, this doesn't change, but the period does. Okay. And how do I find the period of this one? I do 2 pi divided by whatever the absolute value of this is, which is 2, which means the period is now pi, which makes sense. Because if a regular one completes a cycle after 2 pi, if I've stretched it horizontally by a half, that must shrink it by a half. So instead of 2 pi long, it's half 2 pi long, or pi. So what it does when you see it, let's start graphing. Remember, these are going to move in. So at 1, remember, at pi over 2, I'm going to take half of pi over 2. It's going to go here. At pi, I'm going to take half of pi, which is pi over 2. At 3 pi over 2, I'm going to take half of that, and I get 3 pi over 4, which actually, you can see how it flows. And you can see the next one's going to come up here, and the one after that is going to come up here. So it's going to look like this. Wait a minute, let's not do that one just yet. So you can see, here's a regular cycle, horizontal cycle for sine, but it's stretched in by a half. So everything came in by half as much. And then you just follow the pattern of points. That's really all you have to do. So we just go up, back, down, etc. I'm not going to do the whole thing. I'll just stop there. Goes down here, back to the middle, up, back to the middle, down, middle, up, and it follows that. So it didn't change the amplitude, but it did change the zeros. Now there's more zeros occurring. The first one, how do I get the first one? Just go to the right of the y-axis. Find the first zero you see. So pi over 2. But it's not hitting a zero at every pi now. It's hitting a zero at every half pi, or pi over 2. So it's actually pi over 2k, where k is an integer. Nothing changed in the y-intercept or max-min. Hopefully, looking at the next one, you see that, oh, well, if it's 1/2, that means it's going to stretch horizontally by 2, which means it's going to stretch out. Okay? Which makes sense because how do we find how much it takes to complete one cycle? 2 pi divided by 1/2. Well, remember, 2 pi over 1 divided by 1/2 is 2 pi over 1 times 2 over 1, which is 4 pi. So that means it completes a cycle every 4 pi, which we don't even have. So it starts here, but we got to wait until we get to 4 pi before it completes a cycle. So we can't even draw a complete cycle. It goes right off the graph. But we can sketch some of it. Here stays where it is. Remember, I'm looking at the red one. I'm comparing it to the original. Here, it's 2 away, which means its new one is 4 away. Here, it's 2 away. Here, it's 4 away, which means that its new one is 8 away. So you can see how much it stretches. So I've got here it's 3 away. No, sorry. This one is 6 away, so its new one is 12 away. That's going to take me off the graph. So I'm just going to do that. And then it follows the same pattern this side. Oops. Oh, that's sorry. Just want to make sure I didn't. These things didn't change. But the zeros changed. So if I start here and go find the first zero, it's 2 pi, and it's going to hit another zero every 2 pi in both directions. So it starts at 2 pi, and then it's going to hit the zeros again, the x-axis again, every 2 pi, both directions. So k is an integer, positive 1, negative 1, etc. Yeah. Okay, and the last one is not a horizontal stretch. All we're doing is taking the red one and flipping it over the y-axis. That's what the negative means. So the amplitude didn't change. But if you look at the reds, get your points from the reds, right? Okay, so if we take this one, it flips all the way over to here. If we take this one, negative 2 pi, it flips all the way to positive 2 pi. This one flips all the way over to here. And you can see the way the pattern's moving. That's what it's going to look like. The period is still 2 pi, because remember, it's 2 pi over the absolute value, or sorry, over, the absolute value of b, which is 2 pi. So it stayed as it was. Remember, the negative only flips it. And then everything else is going to be the same as this one. So it's pi plus pi k, kei. Y-intercept is still 0. Bottoms out at -1, tops out at positive. Okay. So like I said, the last thing we have to introduce, what happens when it shifts vertically or shifts horizontally. Okay, and then we put it all together to sketch graphs. And that's what the midterm is going to go up to. So we're going to start 5.2 on Friday. I'm not sure if we'll finish it Friday. We'll definitely finish it Monday. That will give us some time to both continue on and do a little bit of review. Okay, because I would like to sort of, like I did with the trig equations, I think I'd like to take some time and stop and get you guys up at the boards graphing these things. I think that would be helpful. So for Monday, exercise 5.1 should be completed.